All right, we're going to keep working with word problems, but first I want to go over a kind of problem you have to sometimes deal with where you have to define two numbers that add up to a given number. So here's an example. The sum of two numbers is 10. In other words, that means two numbers add up to 10. We're going to use one variable to define the two numbers. Okay, so over here, let's just look at some examples. What if I told you the first number was 4? All right, I bet you could figure out the second number, or if one of the numbers was 3, or if one of the numbers was 8. Now, if the first number was 4, what would the other number be if it added up to 10? Well, it'd be 6. Now, how did you get that? You thought 4 plus what is 10 probably, but notice that's also the same thing as just doing 10 minus 4, right? It added up to 10, and so since the first number was 4, I'd have to subtract 4 to get that 6. All right, what about 3? I bet you know the other number is 7, and that's the same thing as just doing 10 minus 3, isn't it? So if we have 10, we subtract the first number, we'll get 7. Now let's say you didn't know what this number was, 8. You couldn't figure out what the other number was. You could get it by doing 10 minus 8, and yes, that is the number 2. So here's the trick. If you know the first number, all right, whatever it is, let's say it's n, how would you figure out what that other number was? All right, do you see a pattern? Look here at my examples. If the number's 4, you do 10 minus 4. If the number's 3, you do 10 minus 3. If the number's 8, you do 10 minus 8. See the pattern? If the number's n and it adds up to 10, it's going to be 10 minus n. All right, so if two numbers add up to 10, you're going to let one number be n and the other one 10 minus n. Now let's say you're still having trouble with that. Let's see if that's really true. Do those really add up to 10? Well, if you take n and you add 10 minus n, right, that's the first number and that's the second number, do you get 10? Yep. You get 10 because the n's cancel. So you can see that those would be two numbers that add up to 10. All right, let's say you're still not convinced, still having a little trouble with this. So let's just say you weren't sure what to do and you wrote the first number is n and you're trying to figure out that second number, which we don't know what we're going to put in here, right? You know that n plus whatever you're going to put in there has to equal 10, right? And how am I going to solve for that box? I'm going to have to subtract n from both sides to get the box by itself on one side. So if I subtract n from both sides, right, what would go in the box is 10 minus n, right? That's what would go in here, 10 minus n. So there again, if the first number is n, the second number would be 10 minus n. Now, what if it added up to another number? What if you were asked to define two numbers that add up to 12? What are you going to put for the first number and the second number? Okay, one number, we're always going to make it easy, just one letter like an X. And what will the second number be if the two numbers add up to 12? 12 minus X, just like the previous problem. All right. Let's see if you could do this one. Define two numbers that add up to 20. All right, let's say the first one is n. You figure out what to put in for the second number. How are you going to define it? 20 minus n. How are we doing? All right, let's try a different one. What if we wanted two numbers that added it up to 30? Okay. So if I said the first one, you can put any letter you want for the first one. How about M? What would the second number, how would you define that? 30 minus M. And make sure that you believe when you add those two things up, you get 30. M plus 30 minus M does equal 30. This first problem, adding up to 12, X plus 12 minus X actually adds up to 12. So you've really got to get this idea in your head because it comes up a lot. So we'll do one more. Two numbers that add up to 45. All right, do it. Define your two numbers. Okay, how about letting the first one be Y? And what would the second number be? defined as? You got it. Oops. 45 minus y. All right, now we're ready to do a problem where something like this comes up. Here's a problem. The sum of two numbers is 18. The sum of 3 times the smaller and twice the larger is 44. Find the numbers. All right, we're looking for two numbers, and more than that, we're looking for a smaller number and a larger number. So instead of just writing the first and second number, we're going to have to define them as the smaller and the larger number. The small number and the large number. Now, you're the one who defines it. You could let the smaller one be n, or you could let the larger one be n. It really makes no difference, but you have to use how you define it when you go on to the next step. So the key is, word of this problem, the sum of two numbers is 18. That's saying two numbers add up to 18. So if one of them's n, what's the other one? 18 minus n. Now, the whole problem is going to look different if you let the large number be n and the smaller one be 18 minus n. But this is how I'm defining it. Now let's go to the rest of the problem. The sum of 3 times the smaller and twice the larger is 44. So we're doing a sum, right? So 3 times the smaller and twice the larger. That's the two parts of the sum, right? The sum has two things you're adding together. So we're adding 3 times the smaller. Now, what did I call the smaller one? I called the smaller one n. So 3 times the smaller will be 3 times n. In fact, let's do this. Let's write this out in words. It's saying 3 times the small number, right? The sum of that and twice the larger number is 44. And now we're just going to plug in what we called the small number and what we called the large number. So we have 3 times the smaller number, which we called n, plus 2 times the larger number, which we called 18 minus n, equals 44. I like the way this looks. Okay, so this is how we would write the equation if this is how we defined the small number and the large number. So let's go ahead and finish that. 3n, and doing the distributive property here. Remember, we're going to distribute our 2. We've got, let's see, 3n plus 36 minus 2n equals 44. So 3n minus 2n is n plus 36. And then we could subtract 36 from both sides to get n equals 8. All right, so n, what did n stand for? That was a small number. So the small number is 8, and the large number is going to be 10, right? Because the sum of two numbers is 18. And now we want to check. What if I take 3 times the smaller number and add it to twice the larger? All right, let's do that. So we're going to check. What's 3 times the smaller number? Well, that'd be 24, right? And then we're going to take 2 times the larger number. 2 times 10 is 20. And that adds up to 44. So, looks like we did it right, that the numbers are 8 and 10. In case you're wondering what would happen if you defined your variables slightly differently, in other words, if you let the small one be 18 minus n and the large one be n, I'm going to show you what that looks like. All right, when we did this originally, we let the small one be n. What if I let the large one be a variable, like x? So I'd have 10 minus x. We're still going to have 3 times the small number plus twice the large number has to be 44. So when I put in the small number, I'm going to put in 10 minus x for the small, and I'm going to put x for the large, and then I'm going to quickly solve this for you so you could see I would get the same answer. Oops, that was a 3. So this was 30 minus 3x plus 2x is 44. So this will give me negative x. Oops, found a mistake. This was 18 minus x. There we go. So this is 18 minus x. So we get, if you follow through the problem, we end up with x equals 10. You still get the large one is 10, and you'll still get the small number is 8, but the equation looks different. When I solve it, it's different. When I solve for my variable, I end up finding out what the large number is first. But in both cases, the small number is 8 and the large number is 10, just like how I did it here. I got the numbers are 8 and 10. Did a different way, defining my variables slightly different. I got 8 and 10.